Welcome to the podcast, Koala Reading AI. I am your host and the voice behind the text-to-speech model. Get ready for an exciting journey through the world of computer vision. In today's episode, we have fascinating papers to discuss. Let's begin with a brief overview of each one. Paper 1, Ensembling Context. Optimization for Vision Language Models. The paper proposes a novel prompt learning strategy that outperforms all competing methods in few-shot learning, with CLIP as a strong baseline. Paper 2, TEDi-Temporally-Entangled Diffusion for Long-Term Motion Synthesis. The paper proposes TEDi, an adaptation of diffusion models for motion synthesis, which produces clean frames and enables synthesizing arbitrarily long motion sequences, with results showing that it outperforms MDM in terms of diversity and produces motion of equivalent or better quality. Paper 3, In Context. Autoencoder for context compression in a large language model. The paper proposes Instruct GPT, a language model fine-tuned with human feedback, which shows improvements in truthfulness and reductions in toxic output generation while having minimal performance regressions on public NLP datasets. Paper 4, Copy is All You Need. The paper proposes a novel neural text generation model, COG, which retrieves semantically coherent and fluent phrases from other documents, and experimental results prove its advantages over strong baselines on 3 experimental settings. Paper 5, MEGA-TTS 2, Zero-Shot Text-to-Speech with Arbitrary Length Speech Prompts. The paper introduces MEGA-TTS 2, a zero-shot TTS system that outperforms state-of-the-art systems in terms of speaker similarity and speech naturalness when utilizing longer speech prompts. Now that we have an overview of these exciting papers, let's take a deep dive into each one. We'll explore the abstract, methodology, and key results of each paper. Paper 1, Ensembling Context. Optimization for Vision Language Models. Abstract, the paper proposes a novel prompt learning strategy for vision language models. The approach optimizes an ensemble of multiple contexts, which are used to generate prompts for the model. The proposed method outperforms existing few-shot learning baselines on 11 benchmarks, varying the number of shots. The paper also provides a comparison between different versions of the proposed method and the baselines. The results show that the proposed method consistently outperforms all the competing methods. Method. The proposed method consists of 2 main components, a prompt generator and a vision language model. The prompt generator generates prompts for the vision language model using an ensemble of multiple contexts. The contexts are generated by sampling from a set of predefined context templates. The templates are designed to capture different aspects of the input image, such as its content, style, and context. The prompts are generated by concatenating the context tokens with a single prompt token. The vision language model is trained using a contrastive loss function. The loss function encourages the model to map the prompts and the corresponding images to the same embedding space. During training, the model is presented with a set of image-prompt pairs. The model is trained to maximize the similarity between the embeddings of the image and the prompt. The embeddings are learned using a transformer-based architecture. The proposed method is evaluated on 11 benchmarks, varying the number of shots. The benchmarks include both image classification and image retrieval tasks. The results show that the proposed method consistently outperforms all the competing methods. The method achieves state-of-the-art performance on all the benchmarks. The paper also provides a comparison between different versions of the proposed method and the baselines. The results show that the proposed method outperforms the baselines by a significant margin. Results: the proposed method has several use cases in the field of computer vision. One potential application is in the field of image retrieval. The method can be used to retrieve images based on a natural language query. The method can also be used to generate captions for images. The captions can be used to describe the content, style, and context of the image. Another potential application of the proposed method is in the field of few-shot learning. The method can be used to train vision language models on a small amount of data. This is particularly useful in scenarios where the amount of labeled data is limited. The method can also be used to transfer knowledge from one domain to another. For example, the method can be used to train a model on a small set of labeled images and then transfer the knowledge to Paper 2, TEDi-Temporally-Entangled Diffusion for Long-Term Motion Synthesis. Abstract. TEDi is a new approach for long-term motion synthesis that entangles the temporal axis of motion with the time axis of the diffusion process. This enables a new mechanism for synthesizing arbitrarily long motion sequences. The gradual nature of a diffusion process that synthesizes samples in small increments constitutes a key ingredient of denoising diffusion probabilistic models, DDPM, which have presented unprecedented quality in image synthesis and been recently explored in the motion domain. TEDi builds on this foundation and introduces a novel entangled diffusion process that can generate long-term motion sequences with high fidelity and diversity. We demonstrate the effectiveness of our approach on several long-term generation tasks, including the ability to plan for upcoming motion using guided generation. Method. TEDi is a new approach for long-term motion synthesis that entangles the temporal axis of motion with the time axis of the diffusion process. This enables a new mechanism for synthesizing arbitrarily long motion sequences. The gradual nature of a diffusion process that synthesizes samples in small increments constitutes a key ingredient of denoising diffusion. Probabilistic models, DDPM, which have presented unprecedented quality in image synthesis and been recently explored in the motion domain. TEDi builds on this foundation and introduces a novel entangled diffusion process that can generate long-term motion sequences with high fidelity and diversity. The proposed method consists of two main components, a motion buffer and a trajectory generator. The motion buffer stores a sequence of motion frames, and the trajectory generator generates a new motion sequence by recursively overwriting the trajectory information in the motion buffer with frames generated by the generator. The generator is based on a diffusion process that generates samples in small increments, which are then combined to form a long-term motion sequence. The entangled diffusion process used in TEDi enables the generator to generate long-term motion sequences with high fidelity and diversity. Results. TEDi has been shown to be effective in several long-term generation tasks. One of the unique applications of TEDi is the ability to plan for upcoming motion using guided generation. This allows the generator to generate motion sequences that are consistent with a given trajectory, which can be used to generate realistic and diverse motion sequences. Another application of TEDi is the ability to generate arbitrarily long motion sequences with high fidelity and diversity. This is demonstrated in Figure 4, where a 33-second motion sequence is synthesized using TEDi. The generated motion sequence is visually plausible and consistent throughout the entire sequence. TEDi has also been evaluated against alternative baselines, and an ablation study has been conducted to assess Paper 3. In-context autoencoder for context compression in a large language model. Abstract. The paper presents a new approach to fine-tuning language models using human feedback. The proposed method, called InstructGPT, trains language models to follow instructions with human feedback. The approach involves fine-tuning a pre-trained language model on a task-specific dataset, where the model receives feedback from humans on its generated outputs. The feedback is used to update the model's parameters, improving its performance on the task. The paper shows that InstructGPT outperforms the state-of-the-art language models in terms of truthfulness and toxicity reduction while maintaining minimal performance regressions on public NLP datasets. Method. The proposed method, InstructGPT, is a fine-tuning approach that trains language models to follow instructions with human feedback. The approach involves fine-tuning a pre-trained language model on a task-specific dataset, where the model receives feedback from humans on its generated outputs. The feedback is used to update the model's parameters, improving its performance on the task. The feedback is collected through a web interface, where human annotators are presented with the model's generated outputs and asked to rate them on a scale of 1 to 5 based on their quality and relevance to the task. The feedback is then used to update the model's parameters using a variant of the stochastic gradient descent algorithm. The proposed method is evaluated on several tasks, including question answering, summarization, and dialogue generation. The results show that InstructGPT outperforms the state-of-the-art language models in terms of truthfulness and toxicity reduction while maintaining minimal performance regressions on public NLP datasets. The paper also shows that InstructGPT can be used to generate high-quality and relevant responses to user queries in a conversational setting. The method is shown to be effective in reducing the generation of toxic and offensive language, making it suitable for use in applications where such language is not acceptable. Results. The results of the paper show that InstructGPT outperforms the state-of-the-art language models in terms of truthfulness and toxicity reduction while maintaining minimal performance regressions on public NLP datasets. The paper presents several examples of use cases for InstructGPT, including question answering, summarization, and dialogue generation. In the question answering task, InstructGPT is shown to generate more accurate and relevant responses to user queries compared to the state-of-the-art language models. In the summarization task, InstructGPT is shown to generate more concise and informative summaries of long documents. In the dialogue generation task, Instruct Paper 4, Copy is all you need. Abstract. The paper Get to the Point. Summarization with Pointer Generator Networks proposes a new approach to text summarization using pointer generator networks. The authors argue that traditional summarization methods, which rely on extractive or abstractive techniques, have limitations in terms of accuracy and coherence. Instead, they propose a hybrid approach that combines the strengths of both methods. The Pointer Generator Network is able to select and copy relevant text segments from the input document, while also generating new text that captures the essence of the original content. The authors demonstrate the effectiveness of their approach on several benchmark datasets, achieving state-of-the-art results in terms of Rouge scores and human evaluations. Method. The key innovation of the paper is the use of pointer generator networks, which are able to dynamically select and copy text segments from the input document. This allows the model to capture important details that may not be present in a standalone vocabulary, while also avoiding the repetition and inconsistency issues that can arise with purely extractive or abstractive methods. The model consists of an encoder-decoder architecture, with the encoder using a bidirectional LSTM to encode the input document into a sequence of hidden states. The decoder then uses an attention mechanism to select relevant hidden states from the encoder and a pointer generator network to generate the summary. The pointer generator network is a combination of a softmax-based generator and a pointer network, which selects text segments from the input document based on their similarity to the decoder state. The authors also introduced several modifications to the standard pointer generator network, including coverage regularization and a hybrid pointer generator/copying mechanism. The coverage regularization encourages the model to select text segments that have not been previously selected, while the hybrid mechanism allows the model to switch between generating new text and copying from the input document based on the decoder state. The authors also propose a novel method for handling out-of-vocabulary words, using subword units to split rare words into smaller units that can be represented in the model's vocabulary. Results. The authors evaluate their approach on several benchmark datasets, including CNN, Daily Mail, and UC 2004. They compare their approach to several state-of-the-art summarization methods, including extractive and abstractive techniques. The results show that their approach achieves significantly higher Rouge scores and human evaluations than the other methods. The authors also provide examples of use cases for their approach, including summarizing news articles and scientific papers. They demonstrate that their approach is able to capture important details and maintain coherence, while also avoiding repetition and inconsistency issues. Overall, Paper 5, MEGA-TTS 2, Zero-Shot Text-to-Speech with Arbitrary Length Speech Prompts. Abstract. The paper presents a new text-to-speech (TTS) system called MEGA-TTS 2, which is designed to synthesize speech for unseen speakers using arbitrary length prompts. The system utilizes in-context learning, ICL, to learn from a few prompts in the context, which is known as in-context learning. MEGA-TTS 2 outperforms state-of-the-art zero-shot TTS systems in terms of speaker similarity and speech naturalness when utilizing a one-sentence speech prompt. Notably, when the length of the prompt is further extended, the performance of the model is significantly improved. These findings highlight the potential benefits of incorporating longer speech prompts in zero-shot TTS systems. Method. The architecture of MEGA-TTS 2 is designed to synthesize speech for unseen speakers using arbitrary length prompts. The system utilizes a VQ-GAN-based TTS architecture as the foundation, which consists of a content encoder, a timbre encoder, and a VQ prosody encoder. To support in-context learning with arbitrary length speech prompts, the system introduces a prosody information language model (PLM) that can utilize arbitrary length speech prompts and a multi-reference timbre encoder (MRTE) to extract fine-grained timbre information from multiple reference speeches. The system further proposes a phoneme-level autoregressive duration model (ADM), which enhances the duration modeling by incorporating in-context learning capabilities. Additionally, the system proposes a prosody interpolation technique to improve the expressiveness of speech from the speaker who has a relatively flat speaking tone. The proposed PLM is a novel approach to incorporating in-context learning in TTS. It allows the system to utilize arbitrary length speech prompts, which is a significant improvement over previous TTS systems that only use a fixed-length prompt. The MRTE is another innovative component of the system, which extracts fine-grained timbre information from multiple reference speeches. This allows the system to synthesize speech that is more natural and similar to the target speaker. The ADM is also an innovative component of the system, which enhances the duration modeling by incorporating in-context learning capabilities. This allows the system to synthesize speech that is more natural and similar to the target speaker. Results. The results of the paper demonstrate that MEGA-TTS 2 outperforms state-of-the-art zero-shot TTS systems in terms of speaker similarity and speech naturalness when utilizing a one-sentence speech prompt. Notably, when the length of the prompt is further extended, the performance of the model is significantly improved. These findings highlight, thank you for listening to Koala Reading AI. Hope you had fun.